Hello everyone, today we are going to do chapter 11, and because I find out that most of the people, they have made videos about the theory part, but none of them have shown the exercises. So I will first start with exercise, and side by side we will cover up some theories also because of lack of time and exams of class 12th are near. So we will start with the exercise questions. Okay, so without wasting the time, let's start. Exercise 11.1, question number 1. Yeah, and I do expect that everyone has studied some theory from somewhere. Okay, otherwise I'll explain everything here. Okay, we'll make it simple. Now question number 1 says that, exercise 11.1, question number 1 says that if a line makes angles, so I am being given with some angles, and in 3-dimension geometry angles are the most important thing. Why? Because if you want to locate something, like in 2-dimensional, you can locate a point here. You just need to know x comma y. What is the value of x? What is the value of y? In 3-dimension also you have the possibility of coordinate system, that you can easily locate a point by x coordinate, y coordinate and z coordinate. This is my x-axis, y-axis and z-axis. But due to some different approach, some people make it appear like we do in complex number, that is called polar representation. If you have studied in class 11, polar representation is also a kind of representation where we use angle and the distance of point from origin. Only two things are required: the angle, which angle it makes with x-axis. Like this is a complex plane, say x and y. There are also we have x and y. Now if this is the point, then everyone knows that I can find out this point using what? This thing. This will be my distance r, polar coordinate, and I need to know cos theta, sin theta also, and for that I need to know this angle. So my approach goes from there, that if you have the angle and if you have the distance r, then you can find the location of the point. It's nothing, just make a circle first of radius r, then we will get this, and then from the origin and to this point, take this as your 0 degree. On this circle, just expand this to here at angle theta. Same is the case here. I want to locate this point in 3D, so what do I need? I need this distance, P, point of observation. Okay, and before this distance can be given with the direction which we study in vector form. I am having this kind of vector, this distance. Okay, but where will it be located? If I only have the distance, it's half of my knowledge. Where will it be located? That is generally given by the angles it make, because these will be unique. If it make this angle alpha, this angle beta, and complete this angle gamma. Okay, mind it, these should be only with the positive x-axis, positive y and positive z-axis. Okay, so these are the angles, that is, this is my alpha, beta and gamma. Clear? Now I need to find what is called direction cosine. Okay, we don't know about the direction yet. We don't have a direction. Okay, but what do we have? We have this angle. So now if I put this angle cos 90 degree, everyone knows that cos 90 is what? 0. So let me take this as my L, which is a usual notation, and then I take cos 135, which can be seen as minus 1 upon root 2, which I take as m, and cos of 45 degree, which is nothing but 1 upon root 2, which is my n. Remember, these are not angles, these are numbers. More precisely, these are value of cos with some angle alpha, beta, gamma. Clear? This tells me the direction cosine. Clear? Because with different angle of cos, we have different value. Like here I have a different value, here I have a different value, here I have different. Now values will start to repeat in these quadrants. Clear? Positive value, negative cos. Clear? But in these two quadrants values will repeat. Again a positive value and a negative value will appear. But why I am not considering that thing? What do we see? That we usually don't take angle greater than 180 degree, because if we have taken complete 180 degree, like my angle is this is my line, and we are only taking the case of x-axis, we are not taking y and z axis. If my angle is this theta, clear? Now extend this is my line. Now if I extend this also will have some angle, say alpha. This is my alpha, because I need to check this with positive x-axis. But if my line is here, why I am checking this angle alpha? Why? I don't need to check, because this is a line, I can extend this here also. So this alpha is a wrong interpretation, because I don't need to do like this. I have line this, unless it's starting from here, means it cannot go ahead. I can make like this, and this is my theta. So it's nothing but just the three values and the cosine. We'll make it simple. What is that? That's just that much, that we need three angles to locate a line, that are generally alpha, beta, gamma, and direction cosines are nothing but cos of alpha, cos of beta, and cos of gamma. These are angles, these are numbers. Okay, so the values which I was given here, these L, M, N were my direction cosine. I don't need to solve this question anymore. Cos 90 equals to 0. This is L, M, and N. These are my direction cosines. Next, question number 2. Find the direction cosine of line which makes equal angles with the coordinate axis. Remember, coordinate axes are nothing but x, y, and z axis. So again a 3D figure. Now my line is like this here, x, y, z axis, and this is my line. Clear? Given condition, what I am given, my line make equal angles. What does this tell me? That instead of taking alpha, beta, gamma, I can say alpha equals to beta equals to gamma. Means this angle will be alpha, this will be alpha, and this will be alpha. All these angles will be what? Alpha. So basically, if all these angles are equal to alpha, 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 clear? Then what will be the direction cosines? And direction cosines are what? Nothing but the cos value of these angles, which is L equals to cos alpha, M equals to cos alpha, N equals to cos alpha. And you might have studied the result that L square plus M square plus N square equals to 1. Why I am going to use this result? Because I need to find some value this thing does not give me value for LMN. No, this is just cos alpha, cos alpha, cos alpha. Here I need some numbers, solution. So for that I have to make an equation, because ultimately my equation will always be get reduced in one variable, that is alpha, alpha, alpha. Like here I can use cos square alpha plus cos square alpha plus cos square alpha equals to 1. This is what equation in one variable, that is alpha. So this gives you 3 cos square alpha equals to 1, and cos square alpha equals to 1 by 3. Take the root both side. This will give you cos alpha. We can choose some margin here so that we don't need to look back again. Okay, we can have cos alpha equals to plus minus 1 by root 3. This was my earlier equation. This is my cos alpha equals to plus minus root 3. Thus the direction cosines of the line which is equally inclined to the coordinate axis, that is direction cosine of the line which makes equal angle with my coordinate axis, x-axis, y-axis as well as z-axis, the direction cosines are nothing but plus minus 1 upon root 3, plus minus 1 upon root 3, and plus minus 1 upon root 3 as well. Clear? Now one more thing. Now I will try to extend this question a little bit more, just a little bit. You can see that these are my direction cosines. What if the person asks you what is that specific angle alpha? Can you find out that angle alpha? So what we can say about this alpha is that we are having this equation. Nothing much but do this cos inverse plus as well as minus 1 upon root 3. This will give you the angle, because from 0 to 90 we don't have any value like 1 upon root 3 with cos alpha. Okay, so we cannot precisely find out this angle in just an instant. We need to do more work. So keeping this aside, we don't need to discuss that thing. We can go ahead to my next question, which is my question number 3 about direction ratios. Question number 3 says that if a line, question number 3, if a line has direction ratios, now see, direction ratios are given, dr is being given, and remember dr are numbers. What we could find out now, direction cosines, and the same thing he have asked in the question, that if you are given, we have seen the procedure that if we are given the angles, then how to find direction cosines. Now we'll see if we are given direction ratios, what are the direction cosines. Okay, so before continuing this question, we need to find out what these direction ratios are. I'm going to make a video on complete lecture after this, where I will explain everything in brief, because the way we are being told is not acceptable, that just cram the solution. No, you need to know from where the things come, where we will use it. Okay, we need to know so that you can also become a good research person. You can have your own good research if you understand where to apply maths, where to do maths. It's all near you. Okay, now we'll discuss only a little bit here about direction ratios. Since we have found out LMN, which we call as direction cosines, now LMN also tells me the location of the line or the point which I need to locate. Instead of angle, I can use these direction cosines also. Direction ratios, as it specify that it is a ratio, but ratio of what? certainly, if I make it easier, nothing but a number, a new number, okay, which satisfy just one condition, that whenever I divide L by my A, M by my by my B, and N by my C, I will get a fixed ratio, lambda. Like if I am having the direction ratio 1 upon root 2 root 3 by 2. Okay, what I have to do is that I can put A equals to 2. Here I will put my B equals to root 2, and here I will put my root 3. Now imagine what is happening. 1 upon 2, isn't it equals to 1 upon root 2 into root 2, that is 2, which is equals to root 3 by 2. This will give you root 3 by 2 cross root 3, which gives you 1 by 2 again, and which is my lambda. So from my L, M and N, I can always find out some numbers A, B and C. These are my required A, B and C. Clear? So that whenever I take the ratio, it will make it constant, which will be equals to some lambda. We can take it K, we can take it some other constant. Okay, now using the result which we used in previous question, L square plus M square plus N square. Now use these values, because compare this and this. What do we have? If I compare this, I have L by A equals to lambda, which further gives me what? That L equals to A times lambda, M equals to B times lambda, N equals to C times lambda. Put all these values here. What do I get? I get my lambda square A square plus lambda square B square plus lambda square C square equals to 1, lambda square equals to A square plus B square plus C square equals to 1, and lambda square equals to 1 upon A square plus B square plus C square, and take the roots both side. What do we get? Lambda equals to plus minus 1 upon under root A square plus B square plus C square. So this is also my lambda, but in terms of what? In terms of A, B, C. And this was my lambda. When I know L, M and N, I can find out some A, B, C, which will make it constant. So now what is the value of L? Value of L is A times lambda. Just multiply here. L equals to lambda, value of lambda is here. So A times plus minus 1 upon under root A square plus B square plus C square. And same way we can find out the value for what? M equals to plus minus B upon under root A square plus B square plus C square, and you can calculate about N. I think everyone is that much smart. Okay, this was all my mathematics which I need to know for this. Now coming to the question, I was given that direction ratios dr was given to me, which was minus 18, 12 and minus 4. These things are very important, direction, cosines, direction ratios, because in higher engineering or higher mathematics, when you will study the flow of something, like flow of water, every particle of water can flow according to your study. That is called fluid dynamics. We study the flow of water. If we study air dynamics, you can create your own aeroplane, design of an aeroplane, that how the air should flow so as to minimize the friction. these things are very important because you need to understand the flow, you need to understand the movement of particle. So unless you have something to describe their location first and then to describe their path, you cannot understand. So this is why we are studying 3D. It's much more useful than people know. Okay, let's see. Yeah, simple. We are given with the, so the direction ratios are -18, 12 and -4. Now if you remember, just now we have seen this. How many things we are needing here? We need this and about n. Remember how we find this out? We are going to use this thing, okay, to find out our question. We are given with the direction cosines. These are this. Then we are given with the direction ratios. We need to find the direction cosines. And direction cosine are what? L, M and N. Direction ratios are A, B and C. I don't think there is a problem in finding L, which was plus as well as minus of A upon under root A square plus B square plus C square. Okay, so for M also I was having N okay, so all of these will give me L by A. If I multiply this A here, cross multiply, I will get my lambda. So depending on the sign of lambda, what kind of sign I want for lambda, I can choose this sign, plus or minus, because if L, M, N are unknown to me and these A, B, C are dependent on L, M, N, so their signs must also be dependent. Means if I want to take my lambda positive, then my A should be positive and my L should be positive, or both should be negative. Only then lambda will come to be positive. Okay, so in this case I want to choose my lambda as positive. I want positive direction cosine for my lambda equals to a positive ratio. So what will I choose? I will choose my formula to be only with plus A. Okay, and this also with plus B, and this also with plus C. So my L becomes -18 upon under root -18 square plus 12 square plus -4 square, which will be equals to saying as minus of 18 upon, solving these three, adding and taking the root, we will get 22 cross 22, which gives you -18 upon 22. And since this is same for all, so M will be equals to what? 12 upon 22, and N will be equals to -4 upon 22. I can further simplify this as 9 by 11, 6 by 11 minus 2 by 11 are my direction cosines respectively. Okay, so why to study direction cosine, direction ratio and the angles separately? Because it depends on what I am studying. Okay, if I am willing to work with my trigonometry, then it's better to take all the locations in terms of angle theta, because there you will definitely get the value. Clear? If you are working with the numbers, your whole 3D question is in numbers, then it's better that you decide to work with direction cosines, because if you are with numbers, then you choose angles. Ultimately you have to reduce them to direction cosines, because angles and numbers you cannot work them out. So it depends what kind of problem we are dealing with, so that we can choose about direction cosine, angles, and the direction ratios are nothing, just ratios which satisfy a certain condition, like this L by A equals to lambda, M by B equals to lambda, N by C equals to lambda. Okay, now coming to the next question. We are not giving so much briefings, as I have told you. We will do that separately, complete theory, and do subscribe us so that we can help other kids, other students, and take the original talent out. Because nowadays we feel that we are being taught in a rubbish way. We need to know how to use this maths so that we can do something really great. Okay, I should start my next question, which is about collinearity. I guess everyone knows collinearity, that 3 points lying on the same line are called collinear points. We have done this in class 10 also, in ratio formula, and then in Euclid geometry also we have seen. Then area of triangle also, there was a question that if 3 points are collinear, area of triangle will be 0. We can see that if 3 points are collinear, using distance formula, AB plus BC should be equals to AC. So now we'll use it here, collinearity, because in 3D also you will have a line. Okay, for the disturbance a little. Okay, we could continue. Yeah, we are given with 3 points. Let us suppose this is my A, then this is my B, and this is my C. This is 7. Okay, imagine these 3 dimension 3 points are really very important. If I tell you an application, just thought, in space we don't have these coordinates. Okay, someone in space far away from Earth, we don't have coordinates, we don't have their 3 dimension, because no one knows now where is X direction, where is Y direction, where is Z direction. You don't have any idea. Okay, but since we know that sun is stationary, I guess, according to what I have studied in my life, and other stars also, they are stationary, they are not moving with high speed. Okay, so if you fix 3 points, then using these 3 points you can find out location of any new points. That is also a very good application of 3D, because in space we don't have X here, Y there, and Z there. No, nothing. But we can fix any 3 things, and then we can locate my 4th thing using these 3 coordinates. Okay, let's start. That was a high talking. ABC, we need to show that these points are collinear. How will I show that these points are collinear? Any guess? Okay, before this we are going to talk about direction ratios a little bit. I hope you all have seen that for any 2 points. Okay, first we'll talk of the basic thing. Okay, first we'll talk my basic thing. This is my basic thing that everyone is familiar with, the term slope, because we are not making much big difference. Okay, if you study 3D with respective to slope, you can find the relation. See, everyone have studied that slope is nothing but the value of this angle theta under my tangent function. Tan theta gives me the slope. Yes, exactly. We have seen that how this angle alpha and then angle beta, and with this axis, okay, we need this here beta, and then in third dimension we have this angle gamma. So here also we are talking about the angles. Then we talk of cos of these angles. Can you see the relation? We are developing a theory based on our previous studies, and there we have something. If I say a formula for slope in terms of coordinate, if you have a coordinate here, you have a coordinate here, let us suppose these are two coordinates x1 y1 x2 y2, then my slope was given as y2 minus y1 upon x2 minus x1. I hope everyone has studied this, and this goes directly equals to tan theta equals to y2 minus y1 upon x2 minus x1. So can anyone tell me what does this gives me? These are direction cosines. Okay, from direction cosine we develop our theory. We came to know about ratios, because ratios are related to direction cosine. Okay, you are being bounded by that lambda. You need to make that lambda fix. So if you have L, M, N fix, and then you have to fix a ratio, then there will be fixed thing A, B, C with which you have to divide and take the ratio. Okay, so if we are talking about ratios, we can talk about direction cosine. Okay. So there is a relation that like this slope, I can find out direction ratios. Remember, I can find out direction ratios. Okay, ratios, not the exact direction cosines. These are just direction ratios because we are using the coordinates. Okay, suppose we are given this line in my 3-dimensional geometry. This is my line. Yeah, in 3D also we have line. Some people confuse that 3D line is different from a plane. No, we can have a line in 3D as well. Okay, and plane will be a different thing. Don't be confused. We will discuss it later. Okay, so if I have this line in 3D, then just simply x2 minus x1 comma y2 minus y1 comma z2 minus z1 gives me the direction ratios of this line A, B. These are the direction ratios. Yeah, the count is 3 because we need 3 direction ratios. Okay, so from here, can we find out direction ratio of AB? Simply subtract minus 1 minus 2. What do we get? Minus 3 minus 2 minus 3. What do we get? Minus 5. Remember, we are finding out the direction ratios of what? Line AB. And the third one is 1 minus 4, which equals to minus 3. So these are my direction ratios A, B and C corresponding to the line AB. Similarly, if you see, subtract this, 5 minus minus 1 will give you 6, I think. 8 minus 3 will give you, 8 minus minus 2 will give you 10, I guess, and 7 minus 1 will give you 6. Now these are what? Direction cosines of which line? BC. Yes. Now, can you find the relation between these two? Observe these. This is minus 3, minus 5, minus 3. Multiply complete with minus 2. What do you get? 6, 10 and 6. Yeah, there is some relation, definitely. If you multiply this with minus 2, then you get this. So these are proportional. These are multiple of each other. And in vectors, if someone has studied about multiplication, then he may know that we are actually talking about the same line or about the parallel lines. Because if direction ratios or direction cosines also satisfy the same property. If direction ratios and direction cosines are same, then the things is that it is parallel. So if the direction ratio dr are proportional, then I can say that these lines AB and BC are parallel. But can a line be parallel like this? No, it should be the single line, because the end point here is the starting point here. So this is nothing but ABC line, that is a single line with these 3 points A, B and C, which are collinear. So collinearity, again if we recall, just find direction ratios and show they are proportional. Remember, proportional also include equality. Okay, if they already comes to be equal, then also you will satisfy the same thing, that it will be collinear. Okay, now the last question. I will leave some parts of this question as a hint. If people don't get it, then we can make it clear. Find the direction cosine of side of triangles whose vertices are. I don't think we need to discuss so much about this thing. Now instead of collinear points, we are having 3 points in triangle. Can you see, we are again developing the same theory which we study in class 10. We study distance formula. First thing, in that we study distance between 2 points, but here we study that distance is not that much important as the importance of alpha, beta and gamma, because distance is not that much important. You can definitely find out this distance in 3D easily, but you need to know these angles, where this line will locate, which will help this line to locate. Okay, then after that we studied section formula, and in section formula we made this conclusion: A, B and C, collinearity of 3 points. Clear? And after that we studied area of triangle in coordinate geometry. There also we studied the same thing, collinearity, if area of triangle is 0. So we are again developing the same thing, we are going in the same line. Find the direction cosines. Now the question number 5 says find the direction cosines of the sides of a triangle. Okay, B is my, C is my, oh it is -2. Okay, so what we need to find? Direction cosine. If you know the direction ratios, can you find out the direction cosine? This is just mix up of question number 3 and question number 4. From question number 4 we can find out x2 minus x1, y2 minus y1, z2 minus z1. This will give you direction ratios of any line. If you choose x1, y1, z1, x2, y2, z2, and then find out the direction ratios, nothing, just use this formula and find out the direction ratios of AB line, AC line and BC line separately. And from the direction ratios, yeah, I think everybody knows how to make the direction cosines also. Just use the formula for L equals to A upon under root A square plus B square plus C square, because these were direction ratio and this was my direction cosine. Formula for M equals to and formula for N equals to. I don't think there is some need to discuss this question, because it's nothing. If you have studied and understood question number 3 and question number 4, I'm sure you can understood question number 5 as well. Don't forget the importance of these things. Okay, don't just leave because this is a small exercise. No, this is equally important. You need to understand all these things. Okay, because by and by again in college also you will
make some higher dimension geometry, you will see solid geometry, you will see there also you will be seeing the same things, collinearity, some formulas, some 3D, some triangles, some circle, planes, lines. So anytime, someday we will definitely come across these things. So better why not study today, give them a shot. If you don't get, then let me know. And for the YouTube viewers, kindly subscribe, please subscribe, so that we can help other students and create some good knowledge with the students so that they can use the creativity. Yeah, someday I will definitely make some videos on how to use maths. Like I give you the example of this. Those who are in little bit hurry, they can leave. Those who want to know some extra knowledge, they can stay. If this is my son, this is my another son, I find out this is my another son 3, I find out these, then in 3-dimension coordinate I will have 3 things here: x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, so fix these things. These are your fix. Now they will work as your origin. If any of these point is new, join it here, join it here, join it here. Clear? Now with the help of these points, 3 points, you can find out this point. You need to know only these few things, few distances which are given in light years.